All right, everybody, grab a seat. We're going to get going here. Okay, everyone, we're going to get started. So this is our normal 9 o'clock Sunday school hour. So we're going to have Dr. Lisle come on up. So you're going to have a different message at 10. So with that, I'm going to turn it over to you, and here we go.
Good morning, folks. It's good to be with you this morning. And in our first session, I'm going to talk about the worlds of creation. And you might say, what does that have to do with church and Sunday school and that kind of stuff? Well, the Lord made these worlds, and He made them for His glory, but for our enjoyment as well, I believe. And I think it's helpful for Christians to know something about the basics of astronomy, because astronomy is one of those fields of science that secularists use to try and persuade you that you shouldn't believe the Bible, because they tell us that the Bible got all the details wrong and that the universe is, 13.8 billion years old. That's the latest number. If you heard a different number, it depends on when you went through the system, which means the previous number was wrong, but you got to believe the new one, apparently. The Bible teaches that God created in 6 days these worlds that you see here, with the exception of Earth. Earth's made on day 1, everything else made on day 4. That's when God made the lights in the firmament. And I want to show you that the solar system really does confirm biblical creation. Helpful for you to know that. It gives you some talking points. If you're talking to someone who rejects the Bible, you can say, well, have you thought about this? The wonderful thing is we've visited all the worlds of our solar system now with unmanned spacecraft, all the large worlds anyway. We've sent spacecraft out. I think it's amazing that we live in a time where that has happened. And we now have detailed images of these planets. And what I'm going to show you today is a simulation, but it's based on real images that have been taken from these spacecraft. And we can take those and wrap them around so we can look at it from different angles. Really neat what we can do with technology today. This is an overhead view of our solar system as it looks right now. That's where the planets are currently, the inner 4 planets that you see there. Mercury, Venus, Earth, and Mars. We're the third one out. And this, the fact that the planets orbit the sun was discovered actually by Aristarchus. He was a Greek astronomer back in a few hundred BC, and then rediscovered by Copernicus and confirmed by Johannes Kepler. Johannes Kepler was the person who figured out that planets don't orbit in perfect circles, but orbit in ellipses, which is kind of a squashed circle. Now, you'll find that in any introductory astronomy textbook, that Kepler discovered the 3 laws of planetary motion that explains how planets orbit the sun, with their paths shown in green there. But what you won't find in most textbooks is that Johannes Kepler was a very devout Christian. He loved Jesus. He calculated the age of the universe at a few thousand years, just as we would today. So he was a biblical creationist. He believed in Genesis. And he discovered that planets orbit in ellipses rather than perfect circles. And he also discovered the rule that governs the speed at which a planet orbits based on its distance from the sun. Inner planets orbit much quicker. You see how Mercury zips around. It takes 88 days for Mercury to orbit once. Venus a little bit longer. Earth takes a year. Mars is about a year and a half, and so on. And Kepler discovered that the period squared is proportional to the distance cubed. Exactly. He was able to figure that out. And it's pretty brilliant. And the thing is, too, I mean, you might say, well, I don't know, I could time the orbit of Mercury and measure that, and then time the orbit of Earth, and I get out a ruler and measure it. He didn't have an overhead view like this. He had a list of numbers recorded by Tycho Brahe, also a Christian. And Tycho had measured the position of Mars in Earth's sky, and using that list of numbers, Kepler was able to figure that out, which is amazing because we're on one of these planets watching the other ones move. Okay? So you have to figure out 2 problems at the same time, Earth's motion and the thing you're looking at. Yeah, he was brilliant. And he was a devout Christian biblical creationist. So this myth that, oh, well, if you're a Christian, you can't be interested in science, and vice versa. If you believe in science, you can't believe in the Bible. That is a myth. It is not true. Most of the founding fathers of the various disciplines of science were Christians. They expected to find patterns in nature because God has imposed order on His creation. So Kepler also discovered the specific way that planets speed up in their orbit when they get closer to the sun. You might notice Mercury is a little bit quicker when it's close to the sun than it is farther away. The outer planets are much farther away, and therefore they orbit much slower. They're just barely moving. I have to really speed up time here, get the inner planets really whipping around there, and then you can see, yeah, that's pretty neat, isn't it? So you can see Jupiter takes 12 years to orbit the sun once. Saturn takes 29 years to orbit the sun once. Anyway, Kepler figured all that out. And then, of course, we have things like comets, too. Comets really show Kepler's second law that, see Halley's Comet up there, up near the top left, there's Halley's Comet. And when it's far away from the sun, it moves very slowly, but then it falls toward the sun. It speeds up. You can see it getting faster and faster. And then it'll really whiplash around the sun. Watch this. Zing, there it goes. And Kepler was able to figure all of that out. So back to the current time. Here's the way they are right now. So all the planets are, if you understand geometry and the way Earth rotates, they're all in the morning sky except for Venus. Venus, you might notice, is that very bright star you've been seeing in the western sky. That's Venus. And often appears as the evening star or the morning star, depending on where it is in its orbit relative to us. So there's the outer planets. All the planets orbit in approximately the same plane. You can see that there. And, I would argue that's a design feature. It keeps them nice and organized. They all orbit in the same direction, in the same plane, very organized. My secular colleagues have an explanation for that too. They would say, well, no, the reason for that, it's not God. It's just that our solar system formed when a nebula, a cloud of gas, collapsed in on itself, and the spinning caused it to have that pancake shape. Well, we'll see that there's some problems with that idea as we go along. And that all supposedly happened billions of years ago. So there's a perspective view of the solar system. We'll go back to an overhead view. Now, the beautiful thing is we've explored each one of these large worlds of creation. We've sent spacecraft past them and taken wonderful images. We're going to start with the sun. The sun is the center of mass of the solar system. And in fact, it's over 99% the mass of the solar system is in the sun. It looks something like that. It is a ball of hydrogen and helium gas. Yes, the sun is made of gas, and it's held together by its own gravity. Yes, gas has gravity. Now, we don't notice that too much here because the Earth's atmosphere is relatively sparse, but the sun has a lot of gas, and that causes it to stay in a spherical shape like that. There are darker regions on the sun. We call those sunspots because we're not very creative, and that's what they are. Those are cooler regions on the sun. The surface of the sun normally is about 6,000 degrees Celsius, and then those little sunspots are about 4,000 degrees Celsius. So they're cooler and they don't give off as much light. They're caused by magnetic fields that inhibit convection from the lower portions of the sun. So there you go. And God placed the sun at the right distance from us to receive the proper amount of heat and light. And Isaac Newton argued that didn't happen by chance. He believed in a creator God, the biblical God. Pretty neat. The sun is a star, or stars are suns if you prefer. Yeah, those little pinpoints of light you see in the night sky are the same type of thing as the sun is. It's kind of amazing. It's just the sun is much closer. It's a nearby 93 million miles away. Okay. All the other stars are much farther than that. They're in the trillions of miles away, even the nearest ones beside the sun. So that's the sun, the center of the solar system and most of its mass. But we'll take a look at some of the planets. We'll start with Mercury, the closest planet to the sun, 3 times closer than the Earth. Mercury is about 1/3 the size of the Earth, looks quite a bit like the moon in terms of this heavily cratered, very barren planet. And that's because Mercury doesn't have much of an atmosphere. And so any rock or anything that comes close to Mercury impacts, and you get an impact crater, and you can see it's full of them. And God might have used process on day 4 when he made Mercury, so that some of those craters might be the last bit of that process, and some have formed since creation. Mercury rotates very slowly. Very, very slowly. And so days would be very long on Mercury. And because it's close to the sun, has no atmosphere, and rotates slowly, the day side gets baked. It reaches a temperature of 800 degrees Fahrenheit. Pretty amazing. And then the night side drops to a couple hundred below zero because it hasn't seen the sun in weeks, Earth weeks anyway. So there you go. So that's Mercury. One of the things that's interesting about Mercury, and that's very perplexing to the secularists, is that Mercury has a magnetic field. And you'll find that magnetic fields are an indication that something cannot be billions of years old, because magnetic fields naturally decay with time. Maybe you've, magnetic fields are caused by electrical current in a planet's core, and electrical current runs down with time, doesn't it? Maybe you've made an electromagnet when you were younger. You take a coil of wire and touch it to the ends of a battery, and you can pick up nails with it. It's kind of neat. Well, planets have that. And batteries run down with time, don't they? Yeah. Now, the bigger the battery, the slower it runs down. Those little AAAs don't last very long, do they? But remember those big D cells? They don't use them too much anymore, but they lasted forever because they're nice and big. They can store a lot of energy. Well, Mercury's a third the size of the Earth. And so it can hold a magnetic field for 6,000 years, not a problem. But if it were 4.5 billion years old, as secularists claim, that magnetic field should be dead. It should be long gone. Should have run out a long time ago, because Mercury is the smallest planet in the solar system, now that Pluto's been demoted. But yeah, so Mercury's kind of the AAA battery of the solar system, but it's still going. And that means that it can't be billions of years old. That was a puzzle to the secularists. But we've been able to confirm that magnetic field with the Mariner 10 and the Messenger spacecraft, both of which flew past Mercury. Now, the next planet out, Venus, has been called Earth's sister planet because it's about the same size as the Earth. Yeah, just 95% the size of the Earth, pretty neat. That's about where the similarity ends. Venus always looks about like that. It's a very bland-looking planet because it has a very thick atmosphere, and those are clouds that circle and completely block the surface of Venus. So secularists were able to speculate endlessly on what might be below the surface, maybe all kinds of alien life forms. You'll see that in the older sci-fi. I still remember an old Outer Limits, back the black and white ones, right? I remember one where William Shatner lands on Venus and it's all scary and everything. It was pretty neat. But that was before they discovered that the surface temperature of Venus is 900 degrees Fahrenheit. So you're not going to have... That wasn't on the Enterprise, no. This was before the Enterprise. Outer Limits was before Star Trek. But he was a very young William Shatner back then. And anyway, so that's Venus. And the reason it has a surface temperature even hotter than Mercury is because of that thick atmosphere. It's 100 times thicker than Earth's atmosphere. 100 times. It would crush you like a tin can, the atmospheric pressure. But then again, the surface temperature is 900 degrees, so that would be a problem as well. And you can't breathe. The atmosphere is toxic carbon dioxide, which you cannot breathe. And those clouds are sulfuric acid. So there's lots of ways to die on Venus. It's not a place you want to visit on your next vacation. But then again, God didn't make it as a vacation resort. He made it to be that beautiful object that you see in the night sky. And check it out this evening. If you take a look west, if we get clear skies, that bright, beautiful, bright object, that's Venus. Now, today we have technology that can go through clouds. The Magellan spacecraft went into orbit around Venus, and it used radar to penetrate the surface. So we now know the surface looks like that. That's the surface of Venus. It's an amazing planet, but it's not a place you want to visit. One of the things that's interesting about Venus is it rotates backwards. The sun would rise in the west on Venus and set in the east, although you'd never see it because of those clouds. But it's rotating the opposite. And that's a problem for that secular view of the solar system where everything supposedly collapsed from a nebula. Because if that were true, everything ought to be spinning the same way due to a principle called conservation of angular momentum. And so just like a skater, when she's spinning and she pulls her arms in and she speeds up and so on, all the planets really ought to be spinning the same way and upright. And Venus is just exactly the opposite of what the secularists would expect. And I sometimes think the Lord does things like that just to confuse the secularists, just to show that he's the one that decides the way planets will rotate and no one else. So Venus is just the opposite of what you'd expect if secularism were true. The next planet out is Earth. It's my very favorite. It's got the best restaurants of any planet. There's Earth. What a beauty. And I think it's wonderful that we have images. Now, this is simulation, but we do have actual images of Earth from space. I think it's wonderful that we live in a time, our ancestors only could have imagined that. And the Earth is beautiful from space. It really is. It's very pretty. That beautiful blue, the liquid water that is abundant on Earth. We think water is essential for all life. All life we know of is water-based. And Earth is, its surface is 71% covered with liquid water. The water molecule is pretty common in space, but liquid water is rare. And so that's kind of interesting because you have to have the right temperature and pressure conditions for liquid water to exist, and Earth has those. Pretty neat. But it also has land, so we can walk around, and that's kind of nice. So there you go. Earth is tilted 23.5 degrees relative to its orbit around the sun. That's what causes seasons. Some people have the mistaken impression that seasons are because we're closer to the sun in summer and farther away in winter. That's not true. We're actually closer in winter than we are in summer. Yeah. But it's because the Earth's tilt. The northern hemisphere is tilted toward the sun in summer. And then on winter, it's on the other side of the sun, so it's tilted away. And that's what causes seasons. You get more daylight hours in summer, and the sun's higher in the sky. You get more direct sunlight and so on. So that causes the Earth's polar ice caps. They grow in winter, they shrink in summer. And we'll find that's a feature that is not unique to Earth. But there it is. So there's the Earth. Didn't always look like that. We think before the flood, the continents were connected. There's some dispute as to exactly what that looked like, but something like that. That's the way the Earth would have looked originally. A little bit different than the way it looks today with the continents all connected. And then during the worldwide flood, those were pushed apart. We think, yes, we do believe in plate tectonics. We think that's the mechanism God used to cause and end the flood. John Baumgartner has a really neat computer model that demonstrates how that could have happened. Pretty brilliant. The Earth has a magnetic field, and we know it's decaying. We've been able to measure it over the last century, and it's dropping, it's declining. Now, that's what causes your compass to work, is the magnetic field. A lot of people have those in your car. My car has one. It tells me I'm going north or whatever. That's kind of a nice feature. But that's caused by electrical current. Electrical current counters resistance. It's decaying. We know it's decaying on Earth because we've been able to measure it. And if you run the equation backwards, we think it's an exponential decay. That's what you'd expect. So it gets really steep. And at creation, the magnetic field would have been 20 times stronger than it is today. So your compass would work really well at creation. And also that magnetic field acts like an invisible shield around the Earth and deflects cosmic rays, these particles that a few of them make it through, but most of them are deflected away. And that's good because cosmic rays are bad for you. They cause mutations. And we'll see tonight that mutations are not something you want. They don't give you superpowers like in the movies. They make you sick. They give you cancer and things like that. So that magnetic field is protective. And people say, well, it's decaying, right? So it's getting weaker and weaker. Yeah, it's true. Could that be why people get sick? Could that be one of the reasons? It could be one of the reasons. Is it going to go away in our lifetime? No, because the decay is gradual. But it is weakening. It is weakening. But if you run the equation back 60,000 years, which in the secular timeline is not that much, you'd find the magnetic field would be stronger than that of a neutron star, which is enough to rip the atoms of your body apart. And so what that means is the Earth can't be even 60,000 years old. It has to be much younger than that. 6,000 would be about right. And so it can't be millions or billions of years old, like the secularists teach. Lots of evidence about that. Earth has a large moon, which we call the moon. Until 1610, it was the only one we knew of. And then Galileo discovered 4 more in 1610 orbiting Jupiter. We'll come to that later. But anyway, the moon orbits the Earth, and that's what makes it a moon. A moon is something that orbits a planet. So the moon orbits the Earth. We always see this side of the moon. And a lot of people think, well, that's because it's not rotating. It is rotating. Otherwise, we would eventually see the other side as it goes around the other side of the Earth. So if you were to watch the moon from space, you'd see it does rotate. It just rotates at the same rate that it revolves around the Earth. So it keeps its same face pointed to the Earth at all times. So we never see that side. Although we got to see it recently. If you watched the Artemis II mission, the astronauts went around the backside of the moon. They got some lovely images of that. There's the Earth in the background there. And you can see, if I lock it in here, you can see the moon is rotating, but it's orbiting the Earth at the same time that it rotates. And that's a common feature. It's called being tidally locked. The moon is tidally locked, keeps the same face pointed at the Earth. All large moons do that. And that's a stability feature. If they didn't do that eventually, they would come to do that anyway. So there you go. The Earth is not tidally locked. You can see it spinning there. So it does not keep its same face pointed at the moon. The moon is a design feature. It keeps the Earth's oceans from stagnating. And that's good. It oxygenates it, because it causes tides on the Earth. And that is a life feature. So God designed even the moon to help life on the Earth. Pretty neat. But you can't live on the moon because there's no atmosphere there. You can't breathe. The astronauts who walked on the moon had to bring a little bit of earth with them in their spacesuit, a little bit of air, water, had to bring food with them, and so on. But there you go. So that's what the moon looks like. The moon has what's called remnant magnetism, which means it has little bits of magnetic field, and that's an indication it can't be billions of years old. So a lot of stuff like that, you tend not to hear it in the secular media because it goes against their narrative. But it's true nonetheless. So there's Earth. Now the next planet out is Mars. And I mentioned earlier Venus is Earth's sister planet because they're the same size. But really Mars is the most like the Earth. It's just not the same size. Mars is about half the size of the Earth. And it's the red planet. Let me get a better map of it here. There we go. That's a better. Okay, so there's Mars. And red planet because it's got lots of iron compounds on its surface that have oxidized. It's like, you know how rust is red? Mars is red for the same reason. It's similar. Lots of iron, oxidized iron compounds on it, on its surface. Mars has a lot of similarities to the Earth. It's got mountains and valleys like the Earth does. It's tilted about the same amount as the Earth, so it would have seasons like the Earth does. It has polar ice caps like the Earth. They grow in the winter, shrink in the summer, just like Earth. That's pretty neat. Although those ice caps are mostly frozen carbon dioxide rather than frozen water. Some frozen water, but mostly frozen carbon dioxide. Mars has a thin atmosphere of carbon dioxide. It's got mountains on its surface. You can see three big ones. If you look at the crosshairs here, there's a big one there, there, and there. And then there's a really big one right there. That's called Olympus Mons. That's the largest known, can you see the crosshairs there? That's the largest known volcano right there. It's 3 times taller than Mount Everest. And the base of it would cover the entire state of Iowa. So it's a very shallow sloping volcano, a shield volcano like the kind you see in Hawaii, rather than the explosive kind you get in the American Northwest. So pretty amazing. It has canyons on its surface too, and other features. This dark feature right here is called Syrtis Major. I always look for that in a telescope. You can see Mars in a telescope. And every 2.1 years, Earth and Mars come really close to each other because Earth is passing Mars. And we get a really good look at it for a few weeks every 2.1 years. And I always try to look for Syrtis Major. And just below it is this light feature right here called Hellas. It sometimes looks almost white by comparison. It's a big valley, sometimes fills in with fog and looks quite bright. People mistake it for the southern polar ice cap, but it's not. It's just close. So, and then there's a big valley, a canyon, enormous canyon right here. You see that? Look like a big scratch mark. That's called Valles Marineris. And it's an enormous canyon about the length of the United States. So it's much bigger than Earth's Grand Canyon. And that's a tectonic fissure where the crust kind of broke apart a little bit. Only Earth has plate tectonics, but Mars does have tectonic activity where the surface can break open like that. Amazing. In fact, you can see it from space. Tells you how big it is. So a lot of features similar to the Earth. Its rotation, 24 hours and 36 minutes. That's kind of neat. I could live with that because you could wake up and you could sleep in an extra half an hour every day, right? That's kind of neat. That's kind of neat. So day and night cycle like the Earth does, seasons like the Earth, they're twice as long, or 50% longer, because Earth's or Mars's year is 50% longer than Earth's year. But yeah, but it has some differences. Very thin atmosphere of carbon dioxide, which you cannot breathe. No liquid water on its surface, at least not in any abundance. In fact, the atmospheric pressure is so thin that normally Mars can't sustain liquid water. It would immediately boil. From ice, it would go straight to vapor, kind of like carbon dioxide does on Earth. Dry ice goes straight from ice. You don't see liquid carbon dioxide on Earth because the atmospheric pressure is insufficient. Regular water would be that way on Mars. So, and it has remnant magnetism, like the moon does, which indicates it can't be billions of years old because magnetic fields decay with time. So lots of differences as well. You can't live on Mars. There's plans to send humans to Mars, but they'll have to bring a little bit of Earth with them. Oxygen from the Earth, water to drink, and air to breathe, and food to eat, and so on. And even then, you wouldn't be able to live there for more than 2 years before the radiation could kill you, because Mars does not have a global magnetic field like the Earth does. And so it's not protected very much from cosmic rays. It gets a little bit of protection from the atmosphere, but not much. So you can only live on Mars a couple years before you'd receive your lifetime limit of radiation and have to come home. back to the confines of Earth. Mars has 2 moons, and they're tiny. They're called Phobos and Deimos. The names mean fear and terror. Mars is associated with the god of war, and so fear and terror accompany war. Here's Deimos. It surprises people. Little moons are not round. They have kind of a random shape. I think it looks kind of like a potato. So it's less than 10 miles across. And so when moons are that small, they don't have enough gravity to pull them into a spherical shape. And so they tend to have kind of a random shape. So there's Deimos. Now Phobos is just a little bit bigger. It's just a little more than 10 miles across. And it orbits very close to Mars. So there's Phobos. Pretty amazing. And if you were on the Mars-facing side of Phobos, you could look up and see Mars in your sky. It would be enormous. I don't know, it'd be kind of a weird feeling, I think. But because Phobos is so small, less than 10 miles across, I mean, you could walk around that little moon and it'd be a nice little hike. I mean, it's something to think about. But the gravity's very weak on Phobos. It's so weak, you could pick up a rock and throw it into orbit. You could watch it go over the horizon, and you better duck or it'll hit you in the back of the head. Isn't that weird? It's weird to think about these situations that just can't occur on the Earth, but they do occur in the other worlds of the solar system. So, lovely planet, fun to watch it every 2.1 years when it comes close to the Earth, which it's not at the moment. Let's go back to the current time. You can see right now Mars is pretty far away from the Earth, but we're getting closer, so there you go. Now, the outer planets are much further away, and they're different from the inner planets. The planets we've looked at so far, Mercury, Venus, Earth, Mars, are called terrestrial, meaning Earth-like. They're rocky. You could theoretically land on them. We have landed probes on Venus and Mars. Okay? Haven't landed humans there, but the outer planets, you can't land on them. There's nothing to land on. They're gas. And we'll start with Jupiter. Jupiter is a ball of gas 10 times the size of the Earth. It's enormous. It's the largest planet in the solar system. Hydrogen and helium gas held together by its own gravity like the sun. But because it's cooler than the sun, it can have the elements can combine and make compounds like methane and ammonia, and that's what gives rise to the beautiful colors that you see on Jupiter. Jupiter rotates rather quickly. It takes less than 10 hours for it to rotate once. And because of that, the clouds tend to get stretched out into these stripes that you see along Jupiter. And you can see those in a small telescope. You'll always see the main two, the equatorial belts, we call those. Belts and zones. The belts are dark, the zones are light. And you can always see those in a small telescope. Jupiter also has a very well-known feature that's rotating around right now. Let me... Right there, just below center, that's the Great Red Spot. And that's an enormous anticyclone. Think of it as a hurricane, but it's a high-pressure system. Hurricanes are low pressure. Storm on Jupiter. And to give you a feel of size, you could put 2 Earths right in that. It's huge. And it's very stable. Hurricanes on the Earth are powered by ocean temperature, ocean heat. When a hurricane moves past a spot on the ocean temperature drops by 10 degrees. And so it's powered by that heat. And then when the hurricane moves over land, it gets cut off from its power source and it kind of peters out. Jupiter has no land. It's all gas. And so that storm has been going on for decades, perhaps hundreds of years, ever since we've been able to see it. And it is shrinking. It is shrinking. That's an image from the 80s. It's a little bit smaller now. But we don't know if it's going to go away or what. It's kind of interesting to watch weather on Jupiter. It tends to be very stable. So pretty interesting. It does rotate, yeah. It's the opposite of what a hurricane would do. Yeah. So a hurricane in the southern hemisphere of Earth, I forget which way it rotates, but it would be the opposite because it's a high pressure system. Yep. Yep. That little black spot you see, that's one of the moons casting their shadow on Jupiter. Jupiter has 115 known moons. 115. 4 of them are big. The remaining 111 are very small. And Galileo, that's one of the shadows of one of the big ones. Galileo discovered the 4 big moons back in January of 1610. And it was the first time human beings had seen moons on another planet. Nobody even thought of that before 1610. There was just the moon. Everybody knows that. And then in 1 week, he discovered 4 more. And he wrote about it in a little booklet that he published called The Starry Messenger. It's a wonderful read. You can read it in a half an hour. It's a wonderful read because you can see his excitement as he presents to the world 4 new worlds that had never been seen before. It's really neat. And he could tell that they orbited around Jupiter because he'd come out one night and they'd be over here, and the next night they'd be on the other side of Jupiter, and so on. You could tell that they were orbiting around Jupiter. And that was proof that not everything orbits the Earth, because there was still doubt at that time as to whether the planets orbited the sun or whether everything orbited the Earth. We knew the moon orbited the Earth, but apparently you don't have to orbit the Earth. He could see that. Really neat. Let's take a look at some of these moons. Oh, before we do that, I do have to point out Jupiter has an enormously powerful magnetic field because Jupiter's 10 times the size of the Earth. It's the D cell of the planets. And so its magnetic field it's actually too powerful for life. It would induce currents in you that would kill you. So it's too powerful for life. But that indicates it can't be billions of years old. Also, Jupiter has internal heat. Did you know that? Jupiter gives off twice as much heat as it receives from the sun. Every second of every day, it's taking in 1, spending away 2, taking in 1, spending away 2, kind of like our federal government, right? Yeah. And like our federal government, it can't do that forever because eventually it runs out of heat. Yeah. So there you go. If it were billions of years old, it should have run out of heat billions of years ago. But the fact that it's still relatively warm indicates it can't be billions of years old. Jupiter is kind of like a potato that you just took out of the microwave. You can feel the heat coming off of it, right? If you come back 2 hours later, do you feel the heat coming off of it? No, it's room temperature. It's emitted all of its heat. So Jupiter is still a hot potato, and that tells you we just took it out of the microwave. Okay, it can't be billions of years old. Let's take a look at some of Jupiter's moons. We'll start with Io, the innermost of the big 4 that Galileo discovered in 1610. We call these the Galilean satellites after Galileo. Oh, I love Io. What a cool looking moon. Isn't that neat? Looks like something like an orange you forgot you left in the refrigerator. And it looks weird like that because it has volcanoes all over its surface. It's made up of sulfuric type compounds. And it's stretched. It orbits in between Jupiter and the next moon out, Europa. And they pull on it, and that induces heat, which produces these volcanoes. Some of the heat might be left over from creation as well. And so all those little spots you see on it, those are volcano craters. So pretty neat. If you've ever been to Yellowstone National Park, if you've gone to the geyser area, the colors are similar. It's because it's similar chemistry. It's sulfuric chemistry. So there it is. You can see it keeps its same face pointed toward Jupiter at all times. All large moons do that. So there's Io, the innermost of the big 4 moons of Jupiter. The next one out is Europa. Io is just a little bigger than our moon. Europa is just a little bit smaller than our moon, just a little bit. And Europa has these scratch marks, especially on the trailing hemisphere. And we think those are probably sites of geysers where they've ejected water up into, and then it falls back to Europa. So pretty amazing. And that would indicate Europa has internal heat, and it's too far away from Jupiter to have significant tidal flexing. So that's an indication that it's not billions of years old. You just tend not to hear about that stuff. The next one out is Ganymede. Ganymede is the largest moon in the solar system. And it's fitting that it orbits the largest planet, Jupiter. So there's Ganymede. Beautiful world. 50% larger than Earth's moon. In fact, it's even bigger than the planet Mercury. But because it orbits Jupiter rather than the sun directly, it's a moon, not a planet. If we could separate it from Jupiter, it would be its own planet. It's big enough. So there's Ganymede. Love that. Those little pockmarked craters you see there with the white ejecta. That's quite beautiful. And then the outermost of the big 4 is Callisto, which we'll cover just for completeness. Slightly smaller than Ganymede, so there's Callisto. And again, you have those white pockmarked craters there. To the astronomer Galileo, these were just little stars next to Jupiter. He had no idea they would have those beautiful surfaces. What a treat that we get to see those today. And amazing. We live in amazing times. Now, the inner moons of Jupiter all orbit in the same plane. And if I speed up time, you can see they all orbit in the same direction, don't they? That's a design feature. There's not a lot of space available there. And so they need to be kind of organized because there's not a lot of space available. It's a design feature. But if we look at the outer moons, they're quite different. Their orbits, now each one of those orbits is a nice, neat ellipse, but they're all in different directions and orientations. And you can see a lot of them orbit backwards. Isn't that interesting? Some of those could be captured asteroids. If we view the system edge on, you can see they're not in the same plane. That's because there's plenty of space available out there. And so the outer moons can kind of do what they want, and there's no chance of collision. It may look very crowded, but they're separated by millions of miles. So, and we'll find that's a common feature of the worlds of the solar system. So pretty neat. Next planet out is Saturn, kind of a smaller version of Jupiter. Saturn's about 9 Earths across. That's just the planet. But of course, the thing that everybody likes about Saturn is that beautiful system of rings. And those rings are trillions of tiny little moonlets that orbit around Saturn's equator. And they give it that striking appearance. But the Lord was kind enough to tilt that planet for us so we could see the rings, because although the rings are hundreds of thousands of miles across, they're about a mile thick, and if it were edge on, you wouldn't see the rings. You wouldn't know that they were there. And by the way, this is the way the planet should look if the secular story were true, because remember, if all the planets formed from a collapsing cloud, they all ought to be spinning upright and in the same direction. Saturn would look like that. We would not know that it had rings. Now, even here, they're casting their shadow on the planet. That's because they're tilted relative to the sun. But if they weren't tilted relative to the sun or the earth, you wouldn't see them. Interesting. But fortunately, the Lord tilted that planet so we could see those rings. Now, when Saturn orbits the sun, it takes 29 years. And so every now and then, because its tilt remains constant, if the sun's here and Saturn's like that, every now and then, they do appear edge on from our perspective. It's not that the tilt changes, but Saturn orbits around the sun. And so every 15 years, they go edge on from our perspective. And for a few weeks, you don't see the rings. It's really kind of neat to see a ringless Saturn, temporarily. But Saturn has a very powerful magnetic field, like Jupiter, and that indicates it can't be billions of years old because magnetic fields decay with time on a time scale of thousands of years. So it's an indication that Saturn, really all the planets have indications that they're not billions of years old. You just don't hear about them, because it challenged the secular narrative. And you say, well, why are seculars so insistent of millions of years? Because they need it for evolution to sound plausible. That's the reason. They'll never give up billions of years. They need it to make evolution sound plausible. Frog to a prince, immediately, that's a fairy tale. All but millions of years, sure, frog can become a prince, right? That's why. That's the story. There's a famous picture of Saturn that looks something like this. It's Saturn in a crescent phase. And I don't think people realize the significance of that. You can't see Saturn like that from Earth. It's proof that we've been there. It's proof that we have sent probes out past Saturn. In order to see something in a crescent phase, you have to be farther away from the object, from the sun, okay, to see it back illuminated. You can see the sun is kind of off that way. So pretty neat. Proof that we've been there. Saturn has a number of moons. The latest count, 293 moons. Most of them are small, and we're going to go through each and every one. No, we're not going to go through each and every one. Let me just did a couple of the neat ones. Titan is Saturn's most famous moon and its largest. It's the second largest moon in the solar system. You can see this in a small telescope. If you look at Saturn, you will always see next to it a faint orange star. That's Titan. And it orbits around Saturn, so you can watch it. If you go out the next night, it'll have moved a little bit and so on. I think 16 days to orbit, something like that. Anyway, there's Titan, and it's the only orange moon. And it's the only moon that has a thick atmosphere. That's rare for moons. Moons usually don't have an atmosphere at all, or if it is, it's very thin. Titan has a thick atmosphere of hydrocarbons. So nitrogen and hydrocarbons, things like gasoline's a hydrocarbon. So it rains like gasoline on Titan. Wow. So gasoline would be cheap. But oxygen would be expensive, so count your blessings, right? I'd rather have to pay for gas and not to breathe, I'm just saying. Again, we can use radar to penetrate that. The Cassini spacecraft we actually went into orbit around Saturn and mapped the surface of Titan. That's what the surface looks like, something like that. It's a radar map. It actually has oceans of liquid methane on its surface, which is wild. And the neat thing about that is methane is destroyed by ultraviolet light from the sun. It converts it into tholins. Tholins are what give the orange color to its atmosphere there. smog, basically. So, but if methane's destroyed by ultraviolet light, why is there still methane left on Titan? I mean, it's been doing it for 6,000 years, but that's not enough there's a lot of methane on Titan. So in 6,000 years, it hasn't had time to get rid of all the methane. But if it were billions of years old, there should be no methane left. It's a huge problem in the secular view. Why is there still methane on Titan? And the answer is it's not billions of years old. It's thousands of years old. And in thousands of years, there's still enough methane left on it. And you can see Saturn there peeking out in the background. Wouldn't that be neat to see that? The next major moon out is Iapetus. I love Iapetus. One of the most interesting moons around Saturn. There's Iapetus. When it was discovered, it was on the right side of Saturn. And then they couldn't see it on the left side. What? Then again, they saw it on the right side. Then they couldn't see it on the left side. What's going on? Well, Iapetus, eventually somebody figured it out. He realized that, if moons keep their same face pointed at the planet, which all large moons do, and a lot of the small ones, if it keeps its same face pointed at Saturn, then when it's on the right side of Saturn, we're seeing one side. When it's on the left side, as it is here, we're seeing the other side. What if one side is really bright and the other side's really dark? And that is, in fact, the case. We're seeing the leading hemisphere here. When it's on the left side of Saturn, that's the dark hemisphere. When it's on the other side of Saturn, you get the snow-covered light hemisphere. Isn't that cool? I just think that's neat. It's beautiful. And we think we know the reason for that. There's Saturn has a distant, what's called a Phoebe ring, that's way out beyond the other ones. And soot collects on the leading hemisphere, and that's what causes it to be dark there. Really interesting little moon. So, and it's not in the plane of Saturn's rings either, which would make Iapetus a nice moon to have a base, so you could enjoy the beauty of Saturn's rings. It'd be kind of neat. Now, back in the 1980s, a wonderful event happened. The outer planets, Jupiter, Saturn, Uranus, and Neptune, lined up in this beautiful arc. And that allowed us to send one spacecraft past all of them, using the gravity of one planet to slingshot it and bend the orbit to the next planet, and so on. Really neat. Doesn't happen very often. It happened right at the time where technology developed to the point where we could send a spacecraft past them. So it's a wonderful act of providence. So in the 1980s, Voyager 2 flew past Jupiter, Saturn, Uranus, and Neptune. And in 86, it flew past Uranus. So this is the way they were lined up in 1986, Jupiter, Saturn, Uranus, and Neptune. And Voyager 2 flew past Uranus. And that's the reason why we have beautiful images of Uranus, because of that wonderful arc that happened. Because it's expensive to put a spacecraft out there, billions of dollars. So we were able to send one and get a great return on our investment. The planet Uranus is tilted on its side in complete defiance of the secular expectation that it should be upright. It's tilted on its side, so it rolls around the sun. Isn't that wild? It has a strong magnetic field. Now, the neat thing about the magnetic field of Uranus is creationists actually predicted it. The creationist Russ Humphreys, back in 1984, predicted the magnetic field of Uranus based on its biblical age of 6,000 years. He said in 6,000 years it sort of decayed this much. So this is the current magnetic field of Uranus. The secularists were saying, what should be magnetically dead? It's 4.5 billion years old. It should have decayed all the way down. The secularists were wrong. Russ Humphreys was right. It does have a magnetic field that's consistent with an age of about 6,000 years. Uranus has a number of moons, and the inner moons orbit around Uranus's equator. So they're also on their side. And let's take a look at least one of those. We'll take a look at Miranda. That's the innermost of the big five. When I was a kid, Uranus had 5 moons. We now know it has 20-some. You keep discovering more. So there's Miranda. Isn't that interesting? And a little moon. Of the big 5, it's the only one I've not been able to see in my telescope. The other, Miranda, Ariel, Umbriel, Titania, and Oberon, I've been able to see faintly. Miranda, it's too close to the planet. And then in 1989, Voyager 2 flew past Neptune, and we got some wonderful images of it. Looks a lot like Uranus, about the same size, 4 Earths in diameter, blue, beautiful blue, due to Rayleigh scattering off the methane. Same thing that makes the sky blue, it's just different molecules. And then we also discovered that Neptune has a great dark spot, kind of like Jupiter's red spot, although this is a low pressure system, so it's a standard hurricane. And unlike Jupiter's red spot, this one goes away and comes back. And sometimes there's a different one that forms in the northern hemisphere. So it's less stable. A few white clouds mixed among the blue. Very beautiful planet. Again, Russ Humphreys predicted its magnetic field back in 84, and it was confirmed in 1989. So its age is about 6,000 years to be consistent with the magnetic field. Neptune has a number of interesting moons. We're going to look at just one of them called Triton. Triton's interesting because it orbits Neptune backwards. So Neptune's going this way and Triton's going just the opposite. And we got some wonderful images of Triton as Voyager 2 flew past. Here's the really interesting hemisphere. Let's zoom in on this a little bit. You can see there are these little black horizontal lines there. And those are geysers on Triton. Now, Triton's smaller than Earth's moon. And it's about 78% the size of our moon. So it's not very big. And yet it has these geysers spewing up nitrogen into a nitrogen atmosphere, and they carry soot with them. And then the prevailing winds deposit the soot in sort of east-west trajectories. That's what's causing those horizontal streaks. But in order to power those geysers, you need internal heat, which means it can't be billions of years old, or those would be long gone. That was really surprising to the secularists, because they assume that this world is 4.5 billion years old. That's the secular age of the solar system, allegedly. And yet, it can't be, because it's got internal heat. This was created by secular standards, 6,000 years ago. Pretty neat. So the geysers on Triton, not to be confused with Titan. Titan orbits Saturn, Triton orbits Neptune. They sound similar, but... So there's the Neptune system. Now, Pluto was not part of that arc back in the 80s, so we had to wait a while. Back in 2006, the New Horizons spacecraft was launched straight to Pluto. I think it might have used a gravitational assist, but we got it there as quick as we could. Took 9 years to get to Pluto, because Pluto's 3 billion miles away. And we were not disappointed by what it found. Interesting. Now, Pluto, in the secular worldview, Pluto's 39 times farther away from the sun than the Earth is. It doesn't get much heat from the sun. It really doesn't. And so it should be a cold, dead, frozen world, especially if it were billions of years old, because if it's billions of years old, any internal heat it started with would have decayed away. It's a small potato. It's not going to maintain heat for billions of years. And there's lots of stuff orbiting at the same distance as Pluto, things that should have hit it over billions of years. And so secularists were expecting a dead world completely covered with craters. You shouldn't have things like mountains and valleys, and it should be completely covered with craters. Now, Pluto does have a few craters on it. You can see some of the larger ones up there. It has a few. But this section right here has no craters in it. Look at that. There's not a single crater there. That's unheard of. If it were billions of years old, everything should have hit it. But in fact, it has this kind of polygonal tessellation that you can see there, and that indicates sort of a convection cells. That was once liquid, and it's overturning, so it's frozen in now. But that means that Pluto had internal heat at one point, and it can't have been billions of years ago, or it'd be completely obliterated by craters by now. Enough heat that it can drive geology, and so you have things like valleys and mountains. There are mountains on Pluto. Like here, you see those? They look like little bumps. Those are mountains. About as tall as the Rocky Mountains, by the way. Made of ice. Ice is as hard as rock at that distance. Covered with a thin layer of tholins from the methane on Pluto. Isn't that interesting? Pluto has 5 moons. One of them is huge, called Charon. Huge compared to Pluto. It's half the size of Pluto. It's called Charon. And likewise, Charon has a few craters, but not very many. That's inexplicable if it were billions of years old. And it has evidence of tectonic activity. See the mountains there? There's an entire mountain chain. There are canyons, and that indicates geology. And that's powered by internal heat, which means it can't be billions of years old. Also has a dark northern polar ice cap, which is kind of interesting. We've never seen that before. So pretty amazing. So Pluto and its moon Charon both have evidence of relative youth. They're not billions of years old. And so what a delight, and what a confirmation of biblical creation, including the biblical time scale. And so I want to end by going back to Earth. One of the astronauts who walked on the moon, Jim Irwin, he later became a Christian. As you might expect, that would be an interesting experience to look up from the moon and see the Earth, this little delicate blue marble suspended on nothing. What an experience. 12 people got to see that. And hopefully we're going back with Artemis 4. But anyway, of all the planets in our solar system, this one's very special because this is the one where Jesus came and died for us, paid for our sins, and then he rose again, proving that he is God. And so Jim Irwin, after that experience, he has this quote. I'm paraphrasing, but it's basically something like this. The amazing thing is not that man walked on the moon, but that God walked on the earth. And I think that's a great sentiment. We do have some resources I'd like to share with you. This presentation, I never do it exactly the same way twice. I don't have any notes up here. I'm just kind of pontificating on what I find interesting. I hope it's been sensible to you. But we have this on DVD, Worlds of Creation, and so you can get that. As well as another presentation called Astronomy Reveals Creation, where we go out beyond the solar system and take a look at things out in space. The book that would go along with this, Taking Back Astronomy, it turns out we're out of stock out there, but if you go ahead and purchase it today, we'll ship it to you for free. So Taking Back Astronomy covers a lot of what I covered today. And we do have this one out there, Stargazer's Guide to the Night Sky. If you want to learn how to enjoy the night sky for yourself from a Christian perspective, that's the book you're going to want to get. It'll show you how to find these things and when's the next meteor shower, things like that. There's one coming up next week, right? The Perseid meteor shower next Wednesday evening would probably be your best bet. You get a decent view on Tuesday as well. The book has all that information in it, including constellations. If you want to get a telescope, what kind you might want to get and how to use it. And telescopes are not like computers that immediately depreciate in value, right? No, they stay the same cost. If you don't like it, you can sell it later for the same cost you bought it. But anyway, it's a lot of fun to look at these things in the heavens and enjoy them. We have a new children's book. This is wonderful. I've been wanting to do children's books for some time. And my colleague Dan Lisle, who is the illustrator at Biblical Science Institute, wrote a book on alien life. That's an interesting topic. Lots of movies covered. Think of how many movies. The most popular movies involve aliens. It's interesting. From Star Wars to Superman. Superman's an alien, right? He's from Krypton. And E.T. and the recent Disclosure Day and so on, which was kind of disappointing. But anyway, check that out. It's a great resource. His Star. What about the star that guided the Magi to Christ? You wondered about that? We have a DVD on that. Created Cosmos takes you on a tour of the universe. We did it just the solar system today. This goes beyond it and shows you the rest of the universe. You want a bulletproof argument for biblical creation? This is it, the ultimate proof of creation. And it's you don't have to know a lot about science. You really don't. It's going to show you that science wouldn't even be possible if biblical creation were not true. We have that on DVD as well. Keeping Faith in an Age of Reason answers over 400 alleged Bible contradictions. I'd encourage you to check that out. Introduction to Logic, how to use your mind rightly into the glory of God. We have a teacher guide for that as well with tests and quizzes. Get Logical is the series I did, Sunday school class series I did covering that topic. Secret Code of Creation shows you that God has built incredible beauty and complexity into an aspect of creation most people have never even thought about, and there's no secular explanation for what you're going to see there. It is stunning. We have that on Blu-ray as well because it's beautiful. And we have a book that goes along with it. You might pick that up, leaf through it. Every picture you see in that book was not drawn by human hands. It's artwork of God, and there's no secular explanation for it. You can get the best of our books together. We do have the book packs here today. This is a great way to get all, and it's not all of our books, but it's most of them, together for a 20% discount. The best of our DVDs, our video pack for 20% discount, or our library pack, the best of our books and DVDs for a 30% discount. That's today and tonight only. And then we do have children's resources as well. Check those out. Please sign up for our free monthly newsletter. Just make sure you put your email address or you'll get nothing, okay? It's an electronic newsletter. Put your email, okay? And then check us out on the web as well, biblicalscienceinstitute.com. We're going to take a 10-minute book buying break, and then we'll come back for the main service. Thank you very much. God bless.